Hi, in today's video we're going to take a look at setting up Emacs with Treesitter and Combobulate. So Treesitter is a parser generator tool that can build a syntax tree, and Combobulate is a package by Mickey Peterson, who does the Mastering Emacs series that enables structured movement and editing with Treesitter. So what I'm going to do is take you through what I've managed to figure out so far with these packages and setting this up on Debian and nixos. Now, what I want to mention is you have different parsers for Treesitter, so it can generate a syntax tree for different languages, and this is a list of all the languages that you can set up. And Combobulate, if I come across here, where is it? Combobulate actually has a list of languages that it works with out of the box: CSS, HTML, JSON, Python, YAML, TOML. And what I've done is, with a bit of help with Gemini, is actually managed to create some other languages. So I've created languages for Bash, C, elisp, and nixos. Now, these may need some work. They may be a bit incomplete, but it's a good start. So what I'm going to do is actually take you through getting this set up. So this is my note so far. What we have here is the resources for Treesitter and Combobulate. There's a video here on YouTube about using Treesitter and Combobulate. So what I'm going to do, first of all, is actually take you through Debian and actually setting up Treesitter on Debian. And there is an issue with Debian, Debian 13, that the parsers only work with particular versions of Treesitter. So first of all, let's increase the size of this here. So on Debian, what you need to do, first of all, is have the latest version of Emacs, which is actually available by default. You can get version 30 with Debian Trixie without having to use backports. And what we're going to do is actually install these packages: libtreesitter dev, libtreesitter 022, and treesitter CLI. And what we're going to do after that is edit our Emacs init.el file and add this code. What we have here is require treesit, and then what we have here is add to list treesit language source a list. And what this is this is a list of languages that are actually supported for a particular parser. And in this example, I only have one set up. And what I wanted to mention is we have the language here, Bash, then the link to the Git repository. And what you'll see here is v020.1. And what this is this is the particular release that works with the version of Treesitter on Debian. You can see there are later releases up here going up to 23. But the release that works with Treesitter on Debian for the Bash syntax is v20.01. And what we can actually do is we can specify here in this little block of code that we want to use that version, that release of the Treesitter Bash syntax for Debian. So what you do is you add this block of code, and what we have here is seq major map, major mode, remap a list, sh mode, bash ts mode. And what this does is this remaps sh mode shell scripts to work with the bash ts treesitter library. So otherwise it would only work with shell scripts that have got a bash shebang. And then what we have down here is a bit of code that will actually open the Treesitter syntax in a side window. So what I'll do is I'll show you Treesitter first of all. So what I'm going to do is actually come in here, and the way that you would actually install the language grammar is by running treesit install language grammar. And then what it's going to do is it will actually prompt you, so you type bash here. And I've already done this. And after you've selected bash, it's going to come up with a series of prompts where you can just press return. And it will then download and build Treesitter bash. And it will actually come up in Emacs, if I come down here, Treesitter. And if I show hidden files, what you'll see here is the languages that I actually have installed. So you'll see libtreesitter bash.so. So you will actually need, I believe, Git, GNU make, and GCC installed on Debian, but I think those are pretty much installed by default for this to actually pull down the repository. So if I now run Treesitter explore mode, and then you can see here I can just type bash, what you'll see is a sidebar come up, a side window come up. And as I scroll down through this, you'll see that is actually generating a syntax tree of the code that is selected. If I come across here, what I can do is if I select bits of this, you should be able to see if I can scroll it down a bit. See if I can get this to select stuff. Why is it not selecting stuff? It should actually select stuff as I'm scrolling through. Let me come through. It should actually come through and actually select things. Oh yeah, there you go. So as I'm selecting that, you can see the text on the left is selected. Variable name, like that. If I come across back to this window, you can see it's actually updated. So we have if here. So the string, it should actually select stuff as I move into it. But basically that's the idea, is it's actually giving you a syntax tree of the code that you've got opened up. So that's Treesitter. And we could just do a we can do a Control X1, or I've actually got a keyboard shortcut that actually dismisses the side window. So Control XWS, is it? Yeah. So that disables the side window. So that's a bash script. If I come across here, do I have this set up as well for elisp, Treesitter explore mode? Now, what you'll notice here is I'm not actually being prompted for the language, and I actually manually have to type in elisp. And what you'll see here is now I have the Treesitter come up on the right-hand side. But as I said, for some languages, what I found is that it will actually prompt you for the language, whereas others you kind of got to manually type it in, and I'm not sure why that is. But that's Treesitter. And what it can be used with is this Combobulate package that allows you to navigate the tree that is created for the language. So that's actually getting Debian 13 set up with Treesitter. That's the first step. So there's two steps to this. One, you need to set up Treesitter and have the languages installed. And the next step is going to be actually installing Combobulate. So what I'm going to do is actually take you through nixos. So the nixos, there are packages available for the Treesitter languages, but the issue is that they're installed in the Nix store, and Emacs doesn't seem to be able to find them, or at least I couldn't get it to work, because as I said, by default, what happens is, just come back here, the default location for the Treesitter languages is going to be in your Emacs directory under Treesitter. You can specify another location, but the issue I had was I couldn't get it to work with the nixos packages. There's also a way you can actually specify with a function where it should look for the Treesitter libraries, but it's easier just to keep them in your Emacs directory. So what I'm going to do is actually just come out into home-manger and show you the packages that we need installed. So this is home-manger installed standalone with nixos. And the packages that we need to have installed so that we can run Treesitter install, Treesitter language, where is it? So that we can actually have this set of languages set up and then run the, Treesitter install language grammar. What we need to have installed is GCC, Git, and GNU make. And what this will allow us to do is download the Git repositories for these languages and actually have them combined and compiled to create the .so files. So on Nix, we have these 3 packages installed. You'd run a home-manger switch, flake, your flake name, and that will install the packages. And then what we have here is the same Treesitter code block that I showed you for Debian, but as you can see in this case, I have a larger set of languages installed. So what I've got installed here is awk, bash, C, CSS, diff, elisp, HTML, JSON, make, nix, Python, and XML. And we have the same block of code here for remapping SH mode to bash TS mode. And we have the Treesitter Explore to open in a side window as we did for Debian. So that's getting Treesitter set up on both Debian and nixos. The next step is actually going to be installing Combobulate. And there's a couple of ways you can do this. Combobulate isn't actually in Melpa. So what you can do is you can use straight, but there is also a way to install this with package VC selected packages. So you may be familiar with package install to install packages. Now I'm using use package. So what we've got here is, this is the top of my Emacs init.el file where we have a startup hook. And then what we do is we're bootstrapping use package. So we're saying, unless package installed, use package, package refresh contents, package install, use package, require use package. And this is the important one here. Seq use package, always ensure T. And what this does is this ensures that any use package code block that you've got set up will automatically install that package. After that, we have the Melpa packages here. So we've got Melpa and Elpa set up. And then what we have before the package initialize is this block of code. Seq package VC selected packages, Combobulate VC backend git URL, and then the URL to the Combobulate package on GitHub. What we do is, after we've got that set up, we run Emacs package VC install selected packages. And what that will do is that will pull down and install Combobulate on the system, basically. So as I said, you can use straight or other methods, but this is something that's actually built into Emacs. And so that's quite a good way to get it up and running. So after we've done that, what we need to do is have a use package block of code for Combobulate. And what I want to do is I haven't actually updated this, so I'm going to need to update that. So what I'm going to do is come across to my Emacs init.el. And so again, this was the block of code we had here. I just showed you Emacs package VC install selected packages. So that's how we install Combobulate. What I'm going to do is just come down first of all to Treesitter. So this is Treesitter. So what we've got here is require treesit. And this is the treesit language source A list. And this is what shows up when you run treesit install language grammar. So what you do is you set up this block of code and then you run treesit install language grammar for each of these repositories that you want to install the language from. There may be another way to actually do this. I think there's something called Treesit Auto, which kind of automates it, but I haven't looked into that. But what we've got here, as I said, we've got awk, bash, C, CSS, diff, elisp, HTML, JSON, make, nix, Python, and XML. And these packages come from this page here, the list of parsers. So you can see here, these are all the Treesitter languages that we can install. So there's some quite obscure ones here. You can have a look through. There's Common Lisp, Git packages. There's a long list of packages you can actually go through and install. There's Markdown, PHP, Perl, that kind of thing. But these are the packages that I've installed that I would probably find useful. So after that, as I said, we have this block of code that I showed you to set SH mode to use bash TS mode. That's the Treesitter mode. So that, as I said, if we run treesit explore mode, I'll do it again, treesit explore mode, bash. You can see this is a shell script. This is a script with a sh shebang instead of a bash shebang. But as you can see, Treesitter is working with this using the bash ts mode because shell script and bash are kind of similar enough. And there isn't a Treesitter language for shell scripts with an sh shebang. Okay, then we have the code to open the side window. And what we have here is Combobulate. So what I've done is I actually created a couple of extra languages, and those are installed in config Emacs Lisp. And what I have in my .config Emacs early-init. Okay, so this is the config Emacs early-init.el. We have add to list load path config Emacs Lisp. And so what that will do is that will load any EL files in that directory. Okay. So what we have here is the use package section, use package Combobulate. And what I've done is actually set up a key, which is Control-C-O-O to activate Combobulate. And what we have here is an init section. And what this is doing is this is saying require Combobulate bash, Combobulate C, Combobulate elisp, and nix. And these are the extra languages that I've set up with a bit of help from Gemini. And as I said, they may be incomplete, they may need some work on them, but you can have a sort of play around with them. And if there's any issues, hopefully we can resolve those and improve the languages. And these are based on the existing languages that come with Combobulate. So after that, what we have here is the hook. So these are the new languages that I've defined. And these are some of the existing ones that ship with Combobulate in addition to the ones that I've defined. So what we have, now I want to mention something. Okay. If you have a look at the GitHub repository for Combobulate, what you'll see is this simple Combobulate setup here. And you'll see in the hook, it has prog mode, Combobulate mode. Now, what this does is this enables all of the Combobulate languages. So if I just scroll back up here, you can see these are the languages that are enabled. And you can see they've got different grammar versions here. So you can see CSS, HTML, JSON, YAML, TOML, Go. Now, the issue is if you use prog mode, Combobulate mode here, what it will expect is that you have all of those languages like Go, YAML, TOML installed. And if you don't, it's going to throw an error when you try and run it. So the way around that is by actually specifying a series of languages that we want to be enabled. And so this will actually get around that issue, because otherwise what will happen is you'll try and open a file and you'll get an error. Let me just fill a cup of tea up. Okay, so what we've got here is we've got bash TS mode, CTS mode, CSS. So these are new ones: bash TS mode, CTS mode, CSS, HTML, JSON. Those are all built in. Lisp mode and Nix mode, another two that are knocked up. And then we've got Python. So this is the Combobulate use package. And what also happens is when you use the, if I come back up to the top, sorry to switch back up here. Okay, so as I said, when you set this package VC selected packages up with Combobulate VC backend, git URL, Combobulate, and then you run package VC install selected packages, if I have a look down at the bottom here, what you'll see is package selected packages, Combobulate, packages VC selected packages, Combobulate VC backend, and the URL. And the way that you update the package is package VC, VC selected packages, upgrade VC, package VC upgrade, because normally you do, or package VC upgrade all. So you know that you would normally run package upgrade all to install selected packages. There's a similar thing for VC as well. Okay, so that's sort of how you get stuff set up. And as I said, that was the early init. So we've got the early init, add to load path. And so this is going to load the new languages that I've set up. So let's actually go through and have a look at Combobulate now. So what I'm going to do is actually come across here. So this is a shell script. So let me just increase the size here. So there's two ways you can actually do this. And there's a difference between how these actually work. So you can actually run Combobulate mode. So you can run Combobulate mode, or you can run Combobulate. And there's a difference in how these actually work. So if I run Combobulate, Control-C-O-O, what you'll see is we get this transient menu come up that actually takes up quite a bit of the screen. And what this does is this is a list of the keyboard shortcuts that you can actually use. Now, you don't actually have to have this menu come up. It's more of a helper screen while you're getting your head around the commands that you can actually run. So I've only just managed to get this set up. So I haven't actually gone too deep into the actual usage of the package. Apart from actually getting the Treesitter set up and then Combobulate and creating the new languages. But what you'll see here is it's divided into sections. We've got navigation and searching, linear, explicit, hierarchical, query. Then we've got editing and marking. So we've got marking, editing, and splicing. And what you notice is some of these commands have actually got different colors. So what this means is, for instance, T, if you press T, it will bring up another sub-menu here that will allow you to execute other functions. Now, the issue with this menu when you have this up is that evil mode won't work. So if I press J, what you see is unbound suffix J. So what happens is when you've got this menu come up, your normal editing keys, as far as I can see, for movement like evil mode don't work. So what we have here is meta. So this is meta A, this is control meta. So if I run meta E, what it's going to do is it's actually going to come down here. So you can see it's jumping between these sections. If I run meta A, it goes backwards. Okay. So what I want to do is I just want to see if I can get to the case statement. So, right, if I go back, so I'm now on case, and what you'll see down here is meta P and meta N. So this is previous sequent and next sequent. And what that basically means is it's going to find the next case statement. So if I do meta N, it's going to jump to the next case statement. And if I do meta P, it's going to jump to the previous one. Okay. And as I said, if I do E, it's going to jump forward. Meta A, it's going to jump back like this. So this is the menu. And as I said, I haven't got into this too much. So by default, as I said, there isn't a bash language for Combobulate. I had to create one with a bit of help from Gemini by using the existing Combobulate languages and kind of rejigging those. So it's got ones for JSON and HTML and stuff. And so what I did was have a look at those and then kind of try and knock up some additional languages. So what I'm going to do is I'm just going to press Control G to dismiss that. So the next way, once that's dismissed, you can see here, I can move up and down. So I'm just going to run Combobulate mode to deactivate it and then run Combobulate mode again. And what you'll notice here is first time you run Combobulate mode, you should see this little activating Combobulate and then this message here. And that opens the transient menu I just showed you. You can see here I can use the normal evil key bindings. And if I run the meta, was it meta M? Was it P? Hang on. Combobulate mode. Was it? See, I forget the keys. And now it's cropping out on me. So, right. Ah, yeah, Control C, O. Right, so it was meta N and P. So let me see if I can get that to work. So meta N and P. So you can see we're in Combobulate mode here. So all the keyboard shortcuts work. So this is meta A going backwards, meta E going forwards. So let's come out of this and have a look at some other languages. So what we've got here is some other languages. We had a look at the Bash. So we'll have a look at Python, which is one of the built-in languages, and then we'll have a look at C, Nix, and elisp. So again, we can run combobulate mode, and I should then be able to, you can see here, running. And what you'll notice is we're getting this little kind of block of code coming up at the bottom is like a tree that's showing where we are in the actual structure of this block of code, which I haven't managed to get working with the languages that I managed to knock up. So that's kind of one issue that needs to be resolved with the ones I've knocked up, is that we're not getting this little tree that comes up in this menu. So you can do, I'll come out, Control-C, O. So another thing I wanted to mention was I thought it'd be nice to have this enabled in a sidebar. You can create a side window, as I showed you for the Treesitter language. However, because this is a transient menu, it doesn't actually work in a side window the same way. And what happens is, you can see it's divided into columns. And if you try and set this in a side window, it will be set to this width. So it'll take up all that kind of screen real estate, and you'll only have a sort of kind of tiny little 2-inch block of Emacs to see your code in. So I couldn't actually get this to come up in a side window. What I did think was, and I said there are some of these options here open another menu. So like if I press T, what you'll see is you have these options for editing, like sequence, node type, node text, sibling, by query. So it wasn't really possible to create a side window that would then show you the other options that you can enable by pressing these keyboard shortcuts. But I mean, it'd be nice if you could have a side window that did that, but transient doesn't seem to work with a side window. So again, let me just come across. So as you can see, I pressed K there by, force of habit, but the only commands that work, as far as I can tell, unless there's something I missed, is these commands when you've got this window open. So we can come up and down like this. Now, because the issue is, this is a really big transient menu, especially with this extra section down here. So as you can see, we've only got this bit of Emacs to actually see the document. So that's not exactly ideal. So I'm just finishing the tea there. So, so you can see here, I've got int selected, and when I'm pressing meta n, it's selecting the int like this, and meta a is previous, and e goes forward like this. Now I haven't actually got into any of these other commands as yet, because as I said, I've only just managed to get this set up, and I just wanted to actually cover getting Treesitter and Combobulate installed, and then actually explore its usage and how you can actually edit stuff. And I'll show you, there's a video on YouTube someone's done about Combobulate that I'll put a link to. So, as I said, I haven't got deeply into this. There are commands like editing, splicing, so you can actually move blocks of code up and down. You can select things. There's a thing called envelope, which allows you to wrap a block of code in another bit of code. So, for instance, if you're in HTML, you could select, an A tag and wrap it in a div or a paragraph or something like that. But I'll press Control G to come out of this. And I go Meta E A, and you can see here we've got this little menu coming up here, which is quite nice and not too distracting. It shows you where you're actually coming through the actual Treesitter sort of syntax, as it were. So that's Python. So what I've got here is C, Nix, and elisp. So again, what we've got here is the C file. So what we can do is, I said, we can run combobulate mode, and I should then be able to run meta N and P to go up along the syntax. But as you can see, we're not getting the little tree we were getting up in the other languages. So that's obviously something that needs to be worked on. As I said, there wasn't that much documentation on actually how you create a new language. So it was a bit kind of hit and miss, kind of knocking these up as to what's missing. So what I'll do is actually, after I've made the video, I may sort of raise an issue on the Combobulate GitHub page and say, look, I've tried to knock this up and these things are missing. Have I missed anything? Are there any additional things I need to add to enable that functionality? But let's run Control-C, OO, and bring up the menu. So, as I said, we've got moving backwards and forwards, like that. And there's ways to select these bits of code and then interact with them and move them up and down and edit them. But I haven't quite got my head around that. The main task was actually getting it working, and then that's the actual next stage. And as you can see down here, we're getting an issue, wrong number of arguments, combobulate string truncate 1. Okay, so that's C. And then we've got Nix. So as I say, I can run Control-C, OO to bring up the menu. Can move up and down. See if I'm build inputs, is there anything there? So when I'm pressing meta N and P, it's switching between the build inputs. You see there's no more matches there. Okay, and as I said, the issue with having the transient menu come up is that you can only use the combobulate command listed here to actually navigate in the document. The evil mode commands like hjk and l don't actually work. See, hjk-l. See, it's coming up with it's picking up, the highlight is actually a defined key for H. So if I come back here, combobulate mode, let me just check this. What? Activate, yeah. So as I said, when you run combobulate mode, you should see this activate combobulate message come up, and that means that the mode is activated and you can actually use the keyboard shortcut. So if I come back here and go to PKGs, see, I can switch between the PKGs there. So I haven't got that far with these languages, but it's a start. So there will be, we'll need to do extra work to get these fully featured the same way that the built-in packages are working. So that's Nix. Then we got elisp. So again, so the one thing I'm not that keen on is some of the keyboard shortcuts, because trying to do it with your left hand is a bit of a stretch for meta and E. So I find that I'm using, one hand to hold down meta and then the other to run these keyboard shortcuts. So let's come across to like use package. Let's find a use package. So I can actually show you it's actually, okay, so use package. I want to use package here. So I can now run meta N, meta P to jump to all the use packages. Like that. And there's this hierarchical the siblings, and that's kind of more like stuff you do with HTML, I guess, where you've got sort of nested div tags, stuff like that is going to move on to the next sibling. And some of the commands might not be applicable in certain languages because of their structure. So if I run, see will any of these work? C, D, P, N. Let's see, forward. So if I do meta, control meta F. Okay, control meta F. Control meta B. You see that's kind of moving through. So they need to do lots of work on actually getting all these keyboard shortcuts working in these languages that I've knocked up. It may be incomplete. So what I'm going to do is actually come across and show you some of the languages. So again, what I've done is, first of all, we have the early-init. So what I've done is actually put these new languages in config Emacs Lisp, and in the early-init, I've got add to list load path, and those. And what we need, come back to Combobulate. So this may be totally wrong, but this is how I've managed to get it to work, is having the Lisp directory set up with the language in them, and then in the use package Combobulate block here, having init and then require, and then the languages followed by the same languages in the hook. Okay, hang on, let me switch across. So what we have in the Lisp directory is these 4 additional languages: Combobulate, Bash, C, elisp, and Nix. And these are based on, if I come into here, Combobulate, what you'll see is these are the built-in languages like Combobulate JSON here. So what you'll see is it has these sort of code blocks here: require, Combobulate, settings, navigation, manipulation, interface, rules, setup, and all these bits of code here, which was a bit hectic to kind of look at. You can see here it's quite deep to actually get your head round. what this actually does. So let's come back into Lisp. So as I said, what I did was actually take some of the existing files and try and actually create new languages from them. And as I said, I did actually get Gemini to kind of try and process some of this stuff to get it to work. But as I said, there may be stuff missing from these files for some of the functionality that we need for the languages. As I said, we didn't get some of the little tree come up, when we were navigating. So what we got here is the kind of same blocks of code. And what I think this is doing is this is kind of the nodes that it's actually using, like if statements for while statements, that it can actually navigate. So this is basically some of the sort of code I sort of came up with based on the existing files that it ships with. So we got bash, we got C. Again, here what you can see is function definition, if, for statement, while, do statement. And again, this may be totally incomplete and wrong in places. There may be some errors, but hopefully it might be a good basis to start from and actually figure out what's missing and then kind of improve them based on the existing languages. Okay. So the other thing I wanted to mention down here is what you have is major mode, C mode, CTS mode. So if you run meta X and TS, what you'll see is these are a list of the Treesitter languages that are enabled with Treesitter and the languages that you've actually installed. So for example, if I come through here, you'll notice there's no elisp or lisp. Okay, I'll switch across to the elisp one. That will make more sense and come down to the bottom. So even though there's no elisp TS mode, apparently what happens is Combobulate actually sort of creates one. It's kind of in the back end. So if I run elisp TS, you'll see there's no TS mode, but there is a lisp mode here. So and also an Emacs lisp mode. And so what this is doing is it's kind of remapping the existing modes to be used with Combobulate, as far as I can sort of understand. And even though there is no elisp TS mode when you run MetaX, apparently, at least according to Gemini, which may not be completely accurate, the package actually sort of creates these sort of in the back end somewhere or something. So the major modes are the modes that Combobulate is actually going to sort of work with. And you can see here we've got the name, the language, and then we've got Nix down here. So what you'll see is Nix mode and Nix TS mode. So if I run Nix mode, you can see we've got that. We've got Nix no TS mode. But what I found is actually just having Nix mode in this section, which is what I originally thought, is you'll actually get an error saying no parsers found. So it looks like even though there is no Nix TS mode or elisp TS mode, that these are actually needed to enable the parser to work properly. So that's basically as far as I've got with this. And as I said, these additional languages may need a lot of work to get them up to scratch and have all the functionality enabled. But that's basically as far as I've managed to get so far. So what I want to do is actually just come up here to the resources. So these are my notes. on everything so far. So what we have is an introduction to Treesitter here. Mastering Emacs, how to get started with Treesitter. The list of Treesitter parsers that you can actually install. So you can see here, there's things like Lua, Make, Ninja, Perl, Python, PHP, lots of different languages that you can actually install. Okay, this is the Mastering Emacs Combobulate Structured Movement Editing Treesitter article. So you can actually have a read through this on what it does and how it works. So I'm not going to read through this, but you can see here, this is sort of screenshot showing the transient menu that I showed you. We've got sort of structured editing. You can see here, here's the splicing. So you can see the splicing, how that works. Dragging, you can also drag stuff up and down. And you can see here, this is stuff in curly braces. So this may only work in languages that kind of support that format or structure, as it were. It also works with multiple cursors, which I haven't looked at. Enveloping. So this is the enveloping that I mentioned, where you can actually wrap a block of code. So you can see here, H1. What it's going to do, I think in a second, it's going to show you how you can actually wrap this in another code block. Okay, maybe not. Language-specific features. So here's the structured movement. And this was the Combobulate GitHub page. Okay, so again, this is by Mickey Peterson, the guy who does Mastering Emacs, which is, a must-read, really. So what is Combobulate? It's under active development, expect bugs. A development branch is usually head of the master branch. So I think I've got I think I may just be on the master branch. I'll have to see how you can actually use the development branch. I haven't really got into that as yet. And this is the explanation. You can see here are some links to how this works and the features that it's got. And what we've got here is some little GIFs that you can actually play that will actually show you how this sort of works. And you can see this is little trees, something that I haven't managed to get up with the languages that I've knocked up, and that's what makes me think the code is incomplete and needs a lot of work. But as I said, it's a starting point. So if I scroll down here, these are things showing all the different features that you can have a look at. But this is what I wanted to show you, is the getting started with Combobulate and the default languages that are supported. And it will show you the modes here. You can see CS mode, CSS, TS mode. So by default, what will happen is it will install it will have parsers for these languages here. Okay, CSS, HTML, JSON, Python, YAML, TOML, Go, JavaScript. But I said the issue is, if you have a look at the simple Combobulate setup, which sort of recommends using prog mode and Combobulate mode, what happens is it will expect all of those languages to be installed on your system. And if, for example, you use this block of code, as far as I can tell, and you don't have the language installed, and then you go to, for example, use it with an HTML file, it will fail and it will say Go is not installed. So that's just one issue I came across, and that's why I set it up this way, to actually specifically use only the languages that I've actually got installed for Treesitter. And what you'll notice here is some of these are listed as like bash TS mode, CTS mode, CSS, TS mode. But these two here, Lisp mode and Nix mode, are set up because, as I said, there's no Lisp TS mode. But, as I said, Lisp, to actually get this to work in the language file, it looks like you actually have to specify sort of elisp TS mode, but in the hook, you actually specify Lisp mode, if that makes sense. So Lisp mode is set up because if I come across here, Lisp mode, hang on, let me find Nix mode. Nix mode, yeah. So, for example, Nix mode is a package that enables Nix syntax highlighting in Emacs. So I have Nix mode installed. I suspect Lisp mode is a default mode enabled with Emacs. And if I come across back to here, so you can see we've got the acquire, combobulate, Nix, and then Nix mode, combobulate. So some of this is just kind of guesswork on my part on getting this set up and working. So some of it may be totally wrong, and I may have got the wrong end of the stick with some of this, but blundering about that, this is about as far as I've managed to get so far. Obviously, I need to do some more reading on how this works, but there is a so I come across okay, unlock the power of Treesitter. So there's a good video here. This is the only video that I could find on YouTube about Combobulate. If you just search for Combobulate, you get a load of other stuff. So search for Emacs Combobulate, and I won't go through and actually play the video, but you can have a look at it, and it will show you some of the features and functions and tips and tricks you can use with the built-in languages to navigate and edit stuff. So that's a good starting point to have a look at, as well as the link documentation. So hopefully this helps you kind of get Treesitter and Combobulate set up. Then you can actually have a look at the sort of built-in languages like Python, HTML, CSS, that sort of thing. And then have a look at trying to create your own languages. And as I said, the ones I've knocked up may need a lot of work doing on them to get all the functionality enabled. So I'll put a link, I'll raise an issue, or not really an issue, but I'll mention on the GitHub page that I did a video about this, and is there anything I've missed in actually getting this set up with use package and the additional languages. And, you know, if you've got any ideas on what needs to be fixed, or if you're a bit of a Emacs elisp guru, then please, you know, have a look at the languages and, you know, make any suggestions on what's missing and what needs to be set up to get all this working. But I couldn't really find anything on this page here. So let me just come down. I think there's, okay. Okay. Okay, don't see a language. If you want your favorite language added, then why not try it yourself? Have a look at the Combobulate JSON for an example. So Combobulate JSON. So if we have a look at the Combobulate JSON. So this is kind of a bit kind of overwhelming to look at sometimes, trying to actually figure out how all of this works. So it wasn't totally obvious to me. And as I said, it was just more of a case of blundering about, trying to get an additional language to work. And as I said, they may be incomplete, there may be errors. That's to be expected. So if you've got any ideas on how we can actually get some additional languages set up with that package, that'd be great. So I'll put links to all this under the video and hope that helps you get set up with Treesitter and Combobulate on Debian-based systems as well as nixos.